Hello and welcome to this Ecotect Analysis webcast. I'm Patrick Mullins and I'm going to be running through in the next hour with you also what Ecotect Analysis is and what it can do for you. What is Ecotect Analysis and what does it do? Ecotect is a sustainable design analysis solution that helps measure the impact of environmental factors on a building's performance. So basically what that means is it will allow you to run several tests, several analyses on the building you've created with your BIM solution, and then determine some results based upon the analysis that you perform. It's a wizard-based, easy-to-use solution that makes it easier for building designers to conduct simulations and visualize the results. From the examples I have up on the screen here, I think you'll agree that it is a very visual piece of software. It will take what can be relatively complex analysis and give you a simple wizard-based solution to run through those analyses in a very user-friendly way. Precisely what sort of analysis can it run? This is just a broad example of some of the analysis available. Within these broad categories there are much more detailed analysis. Shadows and reflections display the sun's position and path relative to the building at any date, time and location. So we can do some shadowing analysis, see the impact our building is having within its environment. Daylighting, calculate daylight factors and luminance values at any point in the model. So how much of the outside daylight is actually penetrating into our building. Again, very simple to use. Solar radiation, visualize incident solar radiation on surfaces over any period. So how much solar radiation is our building receiving? Which faces are receiving the most? Thermal performance, calculate heating and cooling loads for models and analyze effects of occupancy, internal gains, etc. Again, we can run through thermal performance analysis, and I'll be going through that with you in detail. And then last but not least, visual impact. Analyze projection angles, determine obstructions, right to light, etc. And the graphics at the bottom here is giving you a feel for some of the analysis that we're going to be looking at today. Ecotect Analysis and Green Building Studio. Green Building Studio is a subscription benefit of Ecotect Analysis. So if you were to invest in Ecotect Analysis, you are entitled to run Green Building Studio via your subscription website. Sorry, via your Green Building Studio login. You'll notice that there's a summary here of the analysis that are available in each piece of software. By looking at the graph here, you can see there's some crossover in terms of analysis available in both. So common to both will be ventilation, wind analysis, photovoltaic collection and thermal performance. What we're going to be looking at today are some of the other tools that enable you to perform other analysis within Ecotect, i.e. shadows and reflection, daylighting, shading design, and acoustic analysis. So what is it that we have to export so that Ecotect can actually do its job? Well, there are two types of input to Ecotect. One is DXF and the other is GBXML. The DXF is primarily used for geometry-based analysis, overshadowing, ventilation, daylight, solar availability. GBXML is more based upon space-based, thermal performance, solar radiation, and energy demands. So what determines which exports you create from your BIM solution, Revit for example, whether or not it's a DXF or whether it's a GBXML, will be based upon the type of analysis that you wish to perform. The typical workflow within Ecotect would be you'd create your 3D conceptual model. And that would be either with rooms if this were Revit architecture, or spaces if it were Revit MEP. You'll then export either a GBXML file or a DXF file based upon the previous slide, what type of analysis you're going to want to create. We would then import either of those two as appropriate into Ecotect, then make modifications to the properties of the analysis, and then actually see the impact that analysis would have on, also those modifications would have on the building's performance. And then we would go through an iterative process whereby we would make these modifications, see the impact, and carry on with that process until we determine the most efficient design. In detail, I'm going to be concentrating initially within this presentation on the heating and cooling loads workflow. So having just gone through the basic principles of the workflow, now we're going to actually go into detail. So how specifically, what would we do if we were to use Ecotect for heating and cooling loads analysis? Well, as we previously said, we would create a conceptual model, complete in this case with rooms, because this will be space-based analysis. We would export that to a GBXML format, import that GBXML file into Ecotect. To get a ballpark figure, we could initially just turn on the shadows and see what our what the position of the sun is and what the shadows are telling us. Possibly we might want to do a more detailed analysis using solar access analysis, and I'm going to be running through that wizard with you. We would define the properties of the space, because up to this point Ecotect wouldn't know anything about the details of the individual spaces, or zones as they're referred to. So we would quote the desired temperature range, occupancy, usage, etc. We would then calculate the zone loading, possibly armed with the overall loading. We might want to have a detailed examination of the passive gains. Which part of the model is it that has the greatest contribution to the heating and cooling loads? So running a passive gains analysis would give us some sort of indication of that. Then possibly we might want to improve the performance of the building, possibly by making some modifications to the materials used. And then we would compare the figures. And we might run through this several times to get an overall analysis based upon which material we use would determine the overall figures. So first thing then is let's run through a demo. Here we have a building that's been modeled in Revit architecture. Now let's just run through the process. So as we said previously, the first thing is we're going to place down, in this case, some rooms. So we use the room tool. Before we actually place the rooms down, one thing you might want to modify is under area and volume computations, you will want to put a tick here in areas and volumes. Without you doing this, the the space that you define, it won't be bounded by the building. It will extend beyond the building. We're asking it to compute volumes, so therefore anything which has a bounding property, i.e. walls and roofs, will actually clip the space. So it's important that, that you put a tick in this box first of all. And we'll define the spaces as terminating at the wall centers. So now we use the room tool. We drop a room into each part of the building and have these sections already pre-prepared. And as you can see, we can click on the individual room within that space, and here we want to extend the space slightly. As you can see, we're having difficulty here picking the individual room, so a technique that we could use in that case is just to select everything and then filter out what we don't want and keep what we do, in this case just the room. So here you can see the room, the height of the room is such that it doesn't fully extend beyond the roof, so this is something you might well need to check. And then lastly, for the third room, we'll do the same. So just extend these rooms fully upon the boundary. Okay, so now we'll do the export. In this case, GBXML. Here are the 3 spaces that we've defined. If there was an error, then this dialog box would help us to visually see any problem. As we can see at the moment, the space is being bounded nicely. So the next step is to define the properties of the space. We'll define the building type. In this case, it's an office space. Location. If you're connected to the internet, you could use Google Maps to determine your exact location. If not, then you can select from the default city list. Here I'm going to select London. Okay, and possibly account for daylight saving if desired. Okay, so we've defined the spaces and the properties. What sort of complexity do we wish? In this case, I'll go with simple and using shading surfaces. So determine those surfaces which are shading. We're exporting the GBXML file. And now into Ecotect. So first of all, you can see it's a different interface. We have pull-down menus, which we'll be using the calculate menu extensively through this demonstration. And then here we have a series of tabs which will allow us to delve into different aspects of the analysis. First of all, we're going to go and find our GBXML file. So model and analysis data, change the file type to XML, navigate to our GBXML file that we created, and then do the import. So just a little tip for you at this point. We have here a list of the elements that have been imported in from Revit, and here the model elements that Ecotect is going to use to convert. So if a descriptive word appears within the type within Revit, i.e. if the word wall or window or door actually appears within the Revit type, when we come over to Ecotect, the software will automatically successfully guess the type of element. If it's a bit vague, if we have a wall and it doesn't actually say the word wall in the description, then, and if Ecotect can't successfully determine what type of element it is, it will say guess. And then we will have to go and actually tell it. So this is just a little time-saving feature. And I believe later on in the demonstration, we'll actually have to do that. Okay, so we're importing in the GBXML file. I'm going to open this as a new Ecotect file. And the first thing we'll do is we'll flip over into the Visualize tab. So here we can see our building with the spaces. They've successfully been imported in. The first thing we're going to do is to do an initial solar radiation study, i.e. turning on the shadows. So we turn on the shadows. So clearly we can see the location of the sun. For this to be accurate, of course, we're going to have to load a weather file. So the software comes with a library of weather files. So here in this case I've selected London, and then we're asked, do we wish to actually update the global position to match the weather file? Well, that seems sensible, so yes, we'll go ahead and do that. So now the shadows are accurate in terms of the location. If I change to summer solstice, we'll see the shadows will update in real time. So just to demonstrate that, back into winter, we see the shadows change, and then back into summer. So we've got an initial feel for which surfaces within our building are actually receiving the most sun, just by in terms of interpreting where the shadows are. But it's not particularly very meaningful, so let's maybe try and do something which is a little bit more accurate. We can turn on the sun while we're still looking at the shadows, turn on the sun and alter the position of the sun manually and get a feel for the shadows updating. We could also turn on the annual sun path, and by holding down the Shift key we can change the position of the sun in terms of date as well. Okay, let's turn that off. Now let's do a more accurate analysis. So over here on the Calculate tab, we're going to do a solar axis analysis. And then this is the first benefit of Ecotect. Some of these analyses can be quite involved and quite complex, but the designers of Ecotect have tried to make it as easy as they can for us, because we have these wizard-based calculations. So in this case we have 7 steps. We're on page 1. So the first question is, well, what is it we want to do? In this case it's a solar radiation analysis. What is it we want to calculate? So next, we want to specify a specific time, and then we get the opportunity to specify that time range, so it will be the summer. We can graphically modify this, so we can drag and drop or just type in figures. Okay, so period-based values, do we want a cumulative value or an average? In this case it will be average. What is it we actually want to analyze? So it will be the models that are in the object, not an analysis grid, and we'll be showing you an example of an analysis grid later on. And then lastly, shading tables. So just before we actually do the analysis, the software will give us an overview of the previous 6 steps and gives us the opportunity to just confirm that what we've done is correct. Okay, so take a look. Yep, okay. And then this can be quite a time-consuming analysis. So just to speed things up a little bit, we've actually chopped that bit out. So here we are now. The analysis has been calculated, and then we have the results. And as you can see, instantly we have a very visual feedback. So we can determine the colors based upon the graph up here on the right hand side. So instantly we can see those surfaces which are absorbing the most solar radiation. So this would help us make some decisions. I mean, is the building layout in the correct orientation? Do we have the right design based upon the solar radiation that each part is receiving? What about the comfort requirements? Is the building in the best location? So this is immediately giving us the opportunity to determine or to think about the design of the building based upon the analysis. So presently, Ecotect doesn't know anything about the individual spaces. We went through the process of defining rooms within Revit. Those have been imported in. Now we're going to define the properties of those rooms. In the context of Ecotect, those rooms have been converted over into zones. So there were 3 rooms within Revit, and they've been converted over into 3 zones within Ecotect. And here you can see those 3. So in this case, what I'm going to do is to combine 2, and then we can take a look at the properties of those zones. So it's a simple right mouse button, and then we get the opportunity to define the zone management properties. Under the general settings tab, the very first thing we're going to take a look at is the internal design conditions, the humidity, the airspeed, the lux values. So 300 lux in this case, occupancy and operation. So how many people are there in each room? Are they exercising? Are they walking? Are they seated? How often are they in these rooms? So at the moment there's no time-based schedule. So the software does come with a library of schedules. So we can import those schedules. In this case, just flip over into the appropriate folder, schedules. Scroll down until we find the UK. Public holiday. Okay, so then the software will automatically determine those dates, highlight those dates in blue, which are public holidays. But what presently the software doesn't know, we haven't picked up on the schedule, the hours that these individual rooms are occupied. So let's tell it. And possibly we can save this as a custom schedule. Do I wish to add to the list? Yes, I do. And then we can go through using that schedule to determine the occupancy, internal gains, and infiltration rate. So what time period are these values to be used or to be considered? So it's using my schedule then. Okay. So we'll repeat that process, but this time for the second zone. So we have thermal properties. What type of heating and air conditioning is being used? What's our thermostatic range? Which temperature range do we want to be most comfortable? What time are we actually using? How long do we want to be considered? What time scales do we want to be considered? And then let's take a look again, define these properties for the other room. So changing the lux values, again, number of people, whether or not they're doing some strenuous exercise, etc. Using the schedule as we previously defined. Okay, so let's take a look. Let's run through again. Full air conditioning. Find the temperature range and the hours of operation. So nobody there at the weekend. Thermal properties, okay, we're ready to go. So having defined the properties of the individual zones, now possibly we can do some space loading calculations. So before we do, let's just take a look at the preferences. I'm just highlighting this because out of the packet these preferences might well be set to US values. So you'll want to change these to decimal, and while we're at it, pound sterling. So we've defined the properties, now let's actually do the calculation. So now what we're going to do is actually to determine the loads for each and one of those spaces. So what sort of temperature are we going to need to keep these at a comfortable level? So we'll do a thermal analysis. In this case it will be for the space loads. So again we have this wizard based, in this case it's just 2 steps. So very simple, nice and easy to use, easily digestible. So it knows about the 3 zones that we specified. Get the opportunity to change them if we hadn't told it. Okay, so let's do the calculation. So the calculation will start. Again, this can be quite a time-consuming process. So then we flip over into the Analysis tab, and then we're presented with this graphic. So this is a monthly heating and cooling loads analysis. So first of all, that we can see the blue below the horizontal line is the cooling, and the red above is the heating. We can see that we have our 3 zones defined here for each month. And first of all, what it's done is it's given us the maximum and minimum cooling values, heating and cooling values. Okay, so as I would have expected, the most cooling is required in the summer, June, July and August. And then we have a breakdown of the heating and cooling values for each month with a total. And if we see here, no heating required in the middle of the summer and the maximum heating required in December. And we have a total value here. So if we just take a note of that value, because we can also analyze those values for each and every room. But let's go back to all of the zones, and then we have that total value, 9766147. So once again, over into the Analysis tab. This time, let's do a passive gains breakdown. So we determine the overall energy requirements for the building, but what we don't presently know, what is it that's having the most contribution to that loading. So here we can do a passive gains breakdown. Ask it to calculate. Again, this can be a relatively time-consuming analysis, so we just chop that bit out for you. Okay, and once again on the Analysis tab, but this time a different result. If we look at the key running along the bottom, we can see we have different colours, conduction in the red, solar air, direct solar, etc. And if we look at the graphic, we can clearly see that conduction is something that's having a large impact on those loading values for this building. We're getting a large amount of conduction. Now, what we might possibly do is try and improve on this value by maybe changing some of the materials and then returning here and possibly seeing the impact that that would have on our calculation. So this is giving us a visual indication of the contribution of each part of the building into the overall breakdown. So conduction is playing a large part, so let's see what we can do about it. Okay, so there's our overall value. Let's change some of the materials and let's see what impact that has. So here, just a quick way of selecting all of the walls rather than having to go back into the 3D editor and physically pick them. We can do it here from the Analysis tab. We can select an element type, in this case walls, and then the properties of the wall will be highlighted over here on the Selection Information tab. So let's take a look at the properties of the existing material for those walls. Presently it's brick, timber and frame, and we can see the U values and the thermal lag associated with that particular material. If we were to select a different material, we can see that we're getting some different values. So a lower U value and a greater thermal lag. So perhaps we'll set that as our default material and then do the calculation once again and see what impact that has on the total. So run through that analysis again, and then let's just compare those figures. Okay, so select material, run through the calculation, take a look, and if we compare the total figure with the previous value, we can see that we've actually improved the situation. So we were on the 976614. We have some reduction. So again, run through process, selecting different materials, experiment with the overall total heating and cooling requirements. So by manipulating the materials, we can improve on the building's efficiency. And this graph will update in real time. In this case, probably more important, we can see what not to do. Okay, so that was a detailed analysis of heating and cooling loads. Later on, I'm going to give you an overview of some of the other analysis that's available. Here, just a different subject. So what else can we do? Shading design and acoustic analysis. So here we have a different model. This time we're going to take a look at initially solar radiation, but this time it's going to be in the form of a grid rather than on the exterior of the building. So we can cut away. Change our plane that we want to cut in. So again, just quite nice, quite visual. So there's the analysis grid giving us the insulation analysis. So graphically, we can see. Let's show those values in 3D. So again, very visual. We can animate these. Again, it's just useful for demonstration purposes. This happens in real time. So later on you'll be seeing another use for the analysis grid. So let's turn off the analysis grid and We'll take a look at another type of analysis, this time particles. So if we had I beg your pardon, sorry, this time we're going to be looking at the shading analysis. The particles will be coming in a moment. So shading design. So I've selected a window. Now we're going to run through a shading device, generating a shading device automatically to ensure that that particular window is always shaded. So run through the analysis, define the location, specify the relevant timescale, what type of shading design do we want. In this case, number 4, we go for the summary. We just run through, just make sure that the summary represents our individual choices, and then we can see the software has automatically created the shading device for us. So if we turn on the shadows, we can see that that particular window is currently in shade, and it doesn't matter whatever we do to the location of the sun, that particular window will always be shaded. Make this a little bit more meaningful. Again, we can change the annual sun path and possibly change the display so that we're actually looking from the position of the sun, view from the sun's position. Here we go. And then again, changing the location of the sun will automatically update the position of the shadows. So we've used the software to automatically design the shading device to guarantee that that particular window will always be in shade. Now we're moving on to the particles. So we have sound source, and then we can use the software to analyze and visually give us an indication of the reverberation times, etc. In this case, it can either be in the form of rays or particles. So here we're demonstrating rays. So again, a very visual indication of what's going on with this analysis. So we have the sound source, and then we get an indication of what's happening within the makeup of that building. So animate the particles, do another analysis, another calculation, this time in terms of depth. So this could be quite a complex analysis. It just makes it much easier to appreciate the results. You get control over the number of rays and the number of times it bounces. Okay. So that was an indication of some of the tools that are available to us here within Ecotect. Now what I'd like to do is to give you an overview of some of the other tools, some of the other analysis available to you. So let's take a look. This time we'll do a general overview. So here we have an indication of shadow analysis. We can change the time and in real time see the visual effect that that will have on the building if we change the position of the sun, as you've seen before. The shadows update. Likewise, you've seen where we can change to an annual sun path and change those visually. Here we have an interior view. It just gives us a better feeling for what's happening within that space. So again, if we change the time and the date, we get an indication of what's happening with the shadows within that particular room. So, okay, this time we have a cityscape. So what sort of impact is my building going to have on the city? So we can see that we can choose a color and see the shadows that my particular building is casting within its environment. We can see the shadows that are being generated by all of the buildings. So again, very clearly we can see the impact that my particular building is having. If we do a reverse sort, we actually get an indication of the where my building is adding to the shadows. So in this case, it's quite minimal. So it gives us, it's a tool for understanding the impact of our building is having on its environment. So let's go back to the shadows for the building, and now possibly we can change the view to a plan, and this time we can have what's referred to as a butterfly view. So we can see the range of shadows throughout the course of the day, and we can set the start and the end times and get an indication of the full shadow range. Shading design. So this is duplicating what we saw earlier on. In this case we have a building. We're going to pick an individual window. So this is a tool for optimizing the design of the shade for this window. Up into calculations, shading design. So we're going to generate the optimal shading device. Choose the time. What type of shading device do we want? So in this case it's going to be number 4, the summary, as you saw before. So then the software has automatically designed that shading device to guarantee that that particular window would always be in shade. Again, it doesn't matter what we do. If we change the time, visually we can see that that window is always in shade. Different example now. This is part of the building. This time we want to display the sun's rays. Here we have a light shelf, and we really want to prove whether or not that light shelf is effective in shading the interior of the building, in this case that particular room. So here we get a visual indication. We're seeing the rays from the sun, and as we change the time we can see the position of the rays changing. Likewise, we can change the date, and again we get a visual clue. We can also take an elevational view, and we can clearly see here that based upon in May that this light shelf isn't really achieving the desired result. It's not particularly very effective. There's not an awful lot of sun penetrating into that room. So this analysis just makes it easier to understand the performance of the light shelf. So it's a design aid. Solar analysis. So this is, again, a major benefit of Ecotect. Here we're getting a very visual indication of the display, in this case, of solar radiation on the buildings here. We can clearly see those parts of the building which are getting more radiation, solar radiation than others. So this could be quite a complex theory to prove, but here with Ecotect it makes it very much more visual, so it's a lot easier to appreciate the results. It's very visual. It will help us create efficient designs and explain possibly why some of the decisions that were made, why they were made. So again, we can see the gold colors receiving a lot more radiation than the blue. So it's a powerful tool helping us make some informed decisions. So we have a new model. Again, we're running through a wizard, in this case the 7 steps. So instant solar radiation, set the times, again visually or by picking from the drop-down list. What type of analysis was it going to be? Is it cumulative? Is it average? Again, we get the summary. So visually we can see that the gold surfaces, there are potential surfaces for the placement of photovoltaic panels. So just interpreting the results is just a lot easier if you can see it visually. So as I said, it helps us make more informed decisions. So there's no point in placing them here on the rear of the building. We can clearly see that that's not receiving an awful lot of solar radiation. Another example, this time rather than displaying the results on the actual surface of the building, it could be in the form of an analysis grid. Here we have a stadium with a grid showing solar radiation. We have a slide bar on the top of the screen. This slide bar will allow us to control the amount of glazing. And clearly we can see, as we move the slide bar, we can optimize the size of glazing. It gives us a better decision-making process, possibly promote the growth, grass growth, etc. And also considering overshadowing. Now we have daylighting. So not only, of course, is it important for the interior to be comfortable, but we might also want to reduce the energy usage. So we want to have an indication of the daylighting within our building. So here we have an analysis grid displaying the light levels within the atrium. We can turn off the surfaces so we can look inside, and as we move the grid, we can see different results. We can turn on volumetric rendering. So again, looking at the same results in a different way, just makes it very easier to display. Possibly we can change what type of data we're representing. Different options, display different options. So graphically, the visual will update in real time. So now let's take another example of daylighting. Here we have a new model, and this time we want to analyze the amount of daylighting coming in by changing the size of the glazing. So here we have a little wizard that will allow us to change by altering the slide bar. We can change the size of the glazing within the exterior of the building. If we take a wireframe view, we can see the analysis grid, and as we change the glazing size with the slider, we can see the impact that that's having on the daylighting on the grid within the building. So it helps us to come up with that compromise between daylighting and the size of the glazing. So a very powerful result. Alternatively, we can run an advanced script where we can set a target of 6% daylighting and then get the software to automatically alter the size of the glazing accordingly. Different alternative, here we can use a slide bar and actually get the software to design the building, the overall envelope of the building, to guarantee that we're not taking light away from the neighbouring windows. So in this case we're using analysis to actually to drive the design. So the software is automatically determining the outer shape of the building so that we're not robbing light from the neighbouring windows. And then lastly, again an advanced script to determine right to light. So in this case it's a 25-degree plane from a particular window. So again, you can define scripts within Ecotect for what would otherwise be quite complex analysis. Thermal analysis, so this is another example of my detailed demo earlier on. In this case, it's obviously it's important for comfort levels and reducing energy levels, so we're going to investigate the roof construction as we did before, interrogate the material, and then possibly change the material based upon its properties, perform a passive gains analysis, and then interrogate the results. So here we pick the roof, interrogate the material, look at the material properties. In this case it's metal deck insulated. As you saw, we can interrogate the U values. We can also look at the makeup of that particular building, of that particular material. So with the metal deck, we can come over to the Analysis tab and run the passive gains analysis once more, do the calculation. So as you saw before, same indication, but this time for a different building. By choosing a different material, running the analysis again, we can see the impact that will have on the gains, passive gains. Okay, so just running through. Visual impact. So here we have a cityscape, we have an analysis grid in 3D and then 2D, and this is showing us the visual area, those areas that are visible from our development. Again, with an analysis grid, so it's very easy to see what the results, to interpret the results. And we can also change it possibly for a percentage of exposed objects or a percentage of exposed points. So it helps us to better understand the development is having on its environment. We could possibly change the rendering to volumetric. Again, just a different way of displaying the same information. So another example, visibility. This time, how much of the outside world is going to be visible from a given viewpoint. So here within our building, how much of the exterior can we see from any given point? So it helps us determine the feel of the internal spaces. Okay, so you saw an indication here of Revit interoperability. So in this case, we've created a conceptual mass. We're going from within Revit, we're going to export this as a DXF. So choose the appropriate location and name. You saw where we've got a visual indication there of what our DXF would look like. So now we're going to import that into Ecotect. So File, Import, 3D CAD Geometry, choose our file, DXF file. We get the visual indication preview. Auto merge triangles. We can do this at this point, but we won't presently because we'll do that manually. So open up that file, import that in, and here where we get the opportunity to merge coincident triangles. So it just allows us to rationalize the model to make it more efficient. Define a weather file. Yeah, change the global location as you saw before to match the weather file. And then if we pick on the face of the DXF file, we can turn on an analysis grid within that face, auto fit the face, also fit the grid to fit the face. So let's define an offset. So now we're analyzing the individual face of the DXF file. Again, solar analysis, as we did before several times now, we run through the wizard. And then we can see the analysis grid actually on the face of the model. We can turn on the shadows. So we get a visual indication within our DXF file of the solar radiation. This time, different variation. Rather than creating a DXF, now we'll go through the process of the GBXML file, as we did before. So back into Revit, export GBXML. There are the spaces, the rooms that we've previously defined. We run through the process, the options. So simple with shading surfaces. We can look at each individual analytical surface. We can assign a color to the different zones. Export that. Back into Ecotect. Import the GBXML file. So here's an indication of where in Revit we didn't define the element name correctly, and we've got guess as some of these elements within Ecotect. So here we know it's a window. If we scroll down, here we can see there's a guess, and then we can right click and we can, if need be, define the element itself manually. So in this case that was a door. Import that into an existing model. This is a potential problem that you might experience. It depends upon the origins that you've defined within Revit, but it's not a huge problem. We can go to modify. We can set the global origin and reset the world origin, and it just drops it down to the floor again. We can assign individual colors to specific zones. Or material color. Okay, so hopefully that's given you some sort of indication of the potential tools available to you within Ecotect. So if we go back to our PowerPoint presentation, what I'd like to finish off with for you now is just to give you some sort of indication of where you can possibly get some help with Ecotect. So Ecotect, under its help menu, has what are called training packages. So these are exe files that you can download from the Autodesk website and then upload within Ecotect, and it will give you a real-time help actually running through each type of analysis. So here you can see from the help file we have some daylight or some training packages. The first one daylight, the second one the demo, etc. You can gain access to these training packages from the Autodesk website. You will need to download them. So if you do a search for Ecotect Analysis, Services and Support. Under the training section you should find these zip files which you can then subsequently download. What do they actually do for you? So let's take a look. It's very, very easy to use. So having loaded up the training packages, it gives you this interface over here on the right hand side, and in this case I'm going to look at the shadows and overshadowing, drill down into the previous view, and what's really nice with this, you can actually ask the software to perform each operation for you. In this case it's loading that particular file for me. What do I do next? Well, the software will actually highlight in red and it will show you what to do. In this case, load the weather file. Or you can actually get the software to do it for you. So here it will show you what to do if you want to do it yourself, or actually get it to actually do it for you. So do it for me. So again, it's really nice and simple and easy to use. It helps learning Ecotect, makes it very, very easy to run through with some self-help yourself. So I hope you found this informative. I tried to give you an overview of what all Ecotect can do for you and how it does it. What we will do is record this presentation and put it on our website so that if you wish to review, you can.